Well. Look who we have here. Try to learn about the multimeter. Well, don't worry, I got you. You're gonna learn everything that you need to know about this thing in the next 10 minutes. So without further ado, let's get into it. Alright, ladies and gentlemen, this is our multimeter and has 4 sockets that you can plug into. There's 10 amps, milliamps, comm, and input. And what this means is we could take our little wires, as right here. Now, the black wire, it just means ground. And ground is comm. You can kind of tell from this symbol, because this little symbol of like the lines decreasing, that's ground. And ground, if you don't know, is just 0 volts. So this one, there's actually 3 inputs that you could put it into. There's the 10 amp, the milliamp, and the input. Now, you should put it into the input if you're not measuring any amperage or voltage or whatever. So this is like the standard one. But if you're measuring something less than 600 milliamps, then you should use this one. And if you're measuring more than 10 amps, then you should use this one. But for most cases, like 99% of cases, you should be using the input. Now we got to talk about all these little circle settings. I'm going to explain them to you. So the first 2 that I want to explain is DC, and then AC. Now, if you notice, DC, there's like a little line. AC, there's no line. And if you don't remember basic electricity, then AC, it's like a wave, while DC isn't a wave. It's like a flat line. So if you see a flat line, then it's probably DC. If you see a wavy line, then it's AC. Alright guys, so sorry for the shitty quality. We're using the Meta Ray-Bans, but we got our power connected to our power, and we got our ground connected to our ground on the multimeter. So when we turn this thing on, it's going to dispense a voltage. And we're going to see 13.72 volts. And if we look at our multimeter, 13.72 volts. Now we can actually adjust it. So if we like play around with this a little bit, 31.13. And that's DC voltage. That's just proof that this works. Alright class, so for this experiment, we're going to be using AC voltage straight from the wall. So we're just going to put this right here. Don't do this at home, by the way. This is going to like electrocute the neurons in your brain. But anyways, we're going to put these in, and it's actually going to create a shockingly high voltage. So you could see on the meter, I'm going to brighten it up for you, abracadabra, 123 volts, alright? So this is very high power. This is an AC mode, as you could see from the little curvature right here. So that's DC and AC voltage for you. Alright, so the next mode on the circle is the ohmage/continuity mode. For my multimeter, it's all in one, but for yours it might be a little different. But anyways, we're going to be using my fingers as a test experiment. So we're going to put the red probe here, ground probe here, and now we're going to take a look at what the multimeter says. So if you can't see what that says, I'm going to brighten it up. You could see 1.9 mega ohms. And a mega ohm is like millions of ohms. So why I'm putting on my fingers, this doesn't hurt at all, by the way, is because ohmage, the human body can actually store electrical charge, and it can actually conduct through charge. So it's measuring how much resistance my hand has right here, which is in millions of ohms, because my hand is just super resistant to electricity. That's why when you get an electric shock from, say, a metal slat at the playground, you don't instantly die. So the next thing we're going to discuss is continuity mode. So if I put it in select. If I put in select, you're going to see this little icon pop up over here. And this is the universal symbol right here. You could see it also over here. It's like a Wi-Fi looking symbol. But anyways, when you touch 2 probes, they beep. And they beep because they're continuous. So we're going to grab the nearest thing available to me, which is actually this piece of solder. Keep in mind, I'm in a repair shop. But you see, the solder is metal, and the metal is electrically continuous. So this actually makes a pretty satisfying sound. And we're just going to grab another thing. This is a solder, what are they called? It's one of these things. If you put on the probe, okay. Wow, it doesn't even conduct. Alright guys, sorry for the letdown, but let's move on to the next thing. This is the capacitor mode. Sadly, I don't have any capacitors on me because the capacitor fairy ate all my capacitors. But essentially, this actually calculates in nanofarads, if you can see that on the screen. And that's like the industry standard. You're going to be mostly interacting with nanofarads. But I really wish I had a capacitor on me, but I don't. Just take my word. This is the capacitor measuring. This is going to be the symbol for all capacitors. Alright, so the next thing on the big wheel here is a Hertz duty cycle. And essentially what this is this is used for measuring AC voltage. So remember how I said that AC voltage is kind of like a wave? Well, the wave fluctuates a lot. So the Hertz duty cycle essentially measures in like fluctuations in a second. It's pretty advanced stuff, but I'm just going to show you what it does. As you can see, we don't even need to put the ground probe in as 60 hertz. That means that's fluctuating 60 times per second. So very fast fluctuation. That's what makes AC so dangerous. Alright, so the temperature is a little special. We're going to be taking these off, throwing them to the side and putting these on. Now, these are thermocouples. So if you have like a different multimeter, you may not have these if it's like a cheaper model. But I'm just going to show you what they do really quickly. It's not super cool. But anyways, what they do is they just measure voltage, or sorry, not voltage, temperature. So as you can see, 30, it's in Celsius. It went to 29 Celsius. And I'm going to show you something pretty interesting. If you put on a smoking hot soldering iron, which is going to heat up in 3, 2, 1. Alright, it's going to rise like really quickly. See that? 150 degrees Celsius. Now, this thing's a little stupid because my soldering iron is actually reading 460 right now, but I want to solder any wire. But as you can see, yeah, very hot. Going down the wheel, you're going to see the HFE. And what this does is it basically just takes the DC change of a MOSFET or a transistor. I guess giving you a quick rundown. When you have a transistor and you want the DC voltage of it running through it, then you could actually just put the two inputs on the transistor. Again, pretty high level stuff. You're not really going to use this in every day, but it's something good to know, you know? So these three inputs right here, they could kind of be grouped into one little lesson. So remember these sockets I was talking about? Well, you could see microamps and milliamps over here and 10 amps over here. Now, I know that you may not have the same multimeter as me, but essentially what you're going to do is if you have a amperage of any more than maybe 200 milliamps, then you shouldn't be using this one. You got to use the big boy one. Because imagine like this. Imagine if I told you that I was going to tap you and I smacked you in the face. It's sort of like that when you just put a bunch of voltage into the multimeter when it doesn't expect it, and you could brick your device. So it's just something to take a note on. So you already know the setup. I have the red probe connected to the power and the ground connected to the ground probe. And as you could see, there's 18 milliamps on my screen. There's 18 milliamps here. If I adjust it, or sorry, that's the wrong one. As you can see, I'm putting more amps in the current, and you can see 34 milliamps on the screen. Alrighty, so the last thing on the wheel is this little robot arm thing. And what this is a clamp reader. And unfortunately, it's paywalled and it's pretty expensive, so I can't really show you what it does. But what it's supposed to do is, normally, you would need to plug something in to the input and the comm, and then it reads your ampage. But this, if you don't want to break your circuit and put two inputs in and things like that, that's quite an inconvenience. It's quite a hassle. But you can put your clamp in, and you can only, if you just put it into one of these, it's going to read it. It's going to take the electromagnetic field around it, and it's going to read it, and that's going to tell you what your ampage is. So it's pretty advanced technological stuff. But sadly, it's like $100 on Amazon. I couldn't get it for the video. I'm really sorry, but maybe if you subscribe, we could get it. Alrighty, thank you for making it to the end of this video. Now you know everything that you need to know about this thing. So if your family asks you what you learned today at the dinner table, tell them that you learned about this. And if you're not subscribed, then what are you doing? You know what I mean? Like, I did this for you. Why don't you do this for me? Like, you know what I mean? But anyways, that's all. See ya.